Today, let us discuss about the Cayley Hamilton's theorem in matrices. What is this Cayley Hamilton's theorem? So what is this Cayley Hamilton's theorem? Cayley Hamilton's theorem, it says that if A is a square matrix, if A is a square matrix and lambda is the eigenvalue, then A minus lambda I, this is equal to 0, is called the characteristic equation. So this is called the characteristic equation. And so what is that? If A is a given square matrix, then we can always find one scalar lambda which is called the eigenvalue, such that A minus lambda I is equal to 0. This comes from the fact that if for this lambda you can find a vector x such that Ax is equal to lambda x, which implies that A minus lambda I of x is equal to 0, and this A minus lambda I is called the characteristic equation. So this is called the characteristic equation. Now I will give this thing. So if A minus lambda I, see this is, if A is of order n, then this will be a polynomial of order n, that is minus 1 to the power of n lambda to the power of n plus k1 lambda to the power of n minus 1 plus k2 lambda to the power of n minus 2 dot 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 up to kn. This is what you'll have. So this is called the characteristic equation for the given square matrix A if lambda happens to be the eigenvector. Okay, now eigenvalue, lambda happens to be the eigenvalue. Now as per this, what Cayley CHT says is that CHT says that every square matrix satisfies its own characteristic equation. So this is the statement of Cayley Hamilton's theorem. The Cayley Hamilton theorem says that every square matrix satisfies its own characteristic equation. Now you see that this is the characteristic equation. I can prove if in the coming days I will definitely prove how this A will satisfy this characteristic equation. That I will prove in my coming classes. Now, but today for the students of BE first year, this is a theorem where the application or the theorem has to be verified, and the theorem is used to find the inverse of a given square matrix. So it is better know, it is enough if they know the application of this Cayley Hamilton's theorem to a square matrix, verify for verification, and to find the inverse of a square matrix. So this is enough for the first BE students. Now here you see that, so that's why I am skipping that. For the present I am skipping the proof of that, but when definitely it will be done in the coming classes. So you see that, so if A is a square matrix, then as per the theorem of, as per the Cayley Hamilton's theorem, we must have, what is that you will have? It is minus 1 to the power of n. Wherever a lambda comes, you substitute, you replace it with a. So what is that you will have? A to the power of n plus k1, it is a to the power of n minus 1 plus k2, a to the power of n minus 2 dot 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 kn is equal to 0. So this is the statement of Cayley Hamilton's theorem. So given a square matrix A and lambda, if lambda is the eigenvalue, then A minus lambda I is called the characteristic equation. If that be the characteristic equation with respect to the square matrix A, then Cayley Hamilton's theorem states that it satisfies its own characteristic equation. Now the characteristic equation with respect to its eigenvalue is A minus lambda I modulus of that, it is minus 1 to the power of n lambda to the power of n plus k1 lambda to the power of n minus 1 plus k2 lambda to the power of n minus 2, and the last one is a constant. And this particular equation I will call this as A1. So this 1 will be satisfied by the given square matrix A. So this is, so that is what I have written. So as per the statement of, as per the theorem of Cayley Hamilton, it is minus 1 to the power of n into a to the power of n plus k1 into a to the power of n minus 1, that must be equal to your 0. So call this as 2. So this is, I am going to verify this. I am not, as I told you, I will prove this theorem in the coming days, but today I will make you understand how it is. I make you understand by verification only, and also make you understand how we get the a to the power of minus 1 or the inverse of a square, given square matrix, applying the Cayley Hamilton's theorem. That I will do. Okay. Now coming to this, see, let me rub off this. Verify, I will write here. So this is the problem. So this is Cayley Hamilton's theorem. So given A is a square matrix which is given by 1 0 3, it is 2 1 minus 1 1 minus 1 1. So this is given. Verify CHT and find inverse. So this is the problem. So you are given a square matrix A which is equal to this. Now you will verify Cayley Hamilton's theorem. What is Cayley Hamilton's theorem? That I will write now. And also find this a to the power of minus 1, that is the inverse of that. See, what is that you will write? So as I told you what is Cayley Hamilton's theorem. Every square matrix satisfies its own characteristic equation. So we have to verify now. We have to verify. What is that you will verify? Minus 1 to the power of n. It is a to the power of n. See whether this is 0. A to the power of n plus k1 into a to the power of n minus 1 plus dot dot dot. Verify whether this is true. So what is that? We have to verify minus 1 to the power of n where A minus lambda I is equal to 0 is the characteristic equation of A, and lambda is eigenvalue. So what is that? A minus lambda. So given lambda as the eigenvalue of A, then A minus lambda I is called the characteristic equation. Cayley Hamilton theorem states that minus 1, this is the characteristic equation. It's a polynomial in lambda. Now you have to replace that lambda by A and verify that it is equal to 0, because Cayley Hamilton theorem is this. Your characteristic equation is A minus lambda I is equal to 0. So now that you have got the characteristic equation, this is your characteristic equation I have written. Now you have to replace in the characteristic equation C1. Ready? Refer 1. So you see that you refer 1, you will find that in the place of this you will have lambda, here lambda. So you see that we have to verify this. For that, what we do is, now what is that? If, say I will write here, if lambda is the eigenvalue of A, if lambda is the eigenvalue of A, then we must have what? It is A minus lambda I is equal to 0. So if lambda is the eigenvalue of A, then we must, this implies, see what does this imply? It implies that 1, 0, 3, 2, 1, minus 1, 1, minus 1, 1, this matrix minus lambda, and lambda I is nothing but, I have already explained in my previous classes that here I is the unit matrix and it is a 3 cross 3, because A is a 3 cross 3 matrix, therefore I is also a 3 cross 3 unit matrix. So this is 1, 0, 0, 0, 1, 0, 0, 0, 1. So you will have this, and this is equal to 0. Now this is the characteristic equation. So this implies lambda, see this implies it is 1 minus lambda, then it is, see 1, it is 1 minus, this is equal to, I will write one more step for you. So this is nothing but what? Having my space here, I will write, this implies, it implies 1 minus, see I will write here 1, 0, 3, 2, 1, minus 1, 1, minus 1, 1, and take out of I in the modulus, minus lambda 0, 0, 0, lambda 0, 0, 0, lambda, this must be equal to 0. So this must be equal to 0. So this implies, I write here, this implies, see what does this imply? 1 minus lambda, see 1 minus lambda 0, 3, 2, 1 minus lambda, and minus 1, it is minus 1, 1 in 1, 1, it is 1, it is minus 1, again it is what? 1 minus lambda, this is equal to 0. This is equal to 0. So this implies, see, go for the expansion. Now you have to find the determinant value. What is the determinant value? 1 minus lambda, 1 minus lambda into minor. Find the determinant of this minor, that is 1 minus lambda whole square. It is minus into minus is plus, so it is minus 1. Minus, here it is 0. So 0 into anything is 0. So don't worry about this. Please leave it like this. Plus 3 into 2 into minus 1 is minus 1. Minus 1 into minus lambda is 1 minus lambda. So this is equal to 0. This implies, I'll straight away give you the answer and explain. So what is that you will get here is that it is lambda cubed minus 3 lambda squared minus lambda plus 9 is equal to 0. Now this is what you will get by doing this simply. For example, you see that this will be lambda squared, this is lambda squared minus 2 lambda plus 1 on minus 1 will go off. So you see that here lambda squared minus lambda cubed. So I will throw out multiply minus sign, don't worry about that. Then you see that if you are going to go for a simplification, multiply this and this. That means I will write one more step so that you can understand. So this implies I will write here 1 minus lambda into lambda square minus 2 lambda for this and plus 3 into minus 2 minus 1 is minus 3 and this is minus into minus will make it as plus 3 lambda is equal to 0. Now you do this simplification, you will get this from this. So you see that this is what you will get. So it is lambda cubed, you will get it as lambda cubed minus 3 lambda squared minus lambda. It is see, let us, we can go for a verification like this. That means you can go for a verification. Here it is plus 9, it is plus 9. See, now having found, let us suppose that, now I will teach you something different. See, here you see that you have got this is your characteristic equation. As per the CH theorem, that is Cayley Hamilton's theorem, wherever lambda comes, you substitute this a. That means you will get a cubed minus 3a squared minus a plus 9. You have to see whether that addition is equal to 0. Here it doesn't mean that it is 0. Know that it is not 0. It is a 0 matrix. 3 cross 3 0 matrix. Mind that this is not your ordinary numerical 0. It is not your ordinary 0. This is a 0 matrix because you are on the left hand side you have got only what? If you are going to substitute by a, here it is a number, here it is a number. But when you are going to verify Cayley Hamilton's theorem, you see that here you will replace this lambdas by a's, in which case if you are going to verify the right hand, it must become 0. It is not your ordinary 0, it is nothing but a 0 matrix. You must know, you must deeply understand all these aspects. Every aspect is very, very important. So this is, now I will tell you check. What is the check? If you go through like this and try to verify whether you have got the proper characteristic equation. Only when you are assured of the proper characteristic equation that you have arrived, verification will not, you cannot verify, it will give a wrong answer. So first and foremost thing that you must ensure that the characteristic equation is properly arrived. Now I will tell you what it is. See, it tells, suppose you have got a square matrix A, then you see that let us suppose that it is a 3 cross 3 matrix. It is a 3 cross 3 matrix. When it is a 3 cross 3 matrix, then you see that your characteristic equation will be lambda cubed minus, it is the, see, it is the diagonal, sum of the diagonal elements. Sum of diagonal elements into x squared minus x into, what is that you will do now here? X into, you will go for x into within brackets. It is, you will go for the, sum of the determinants with respect to diagonal elements plus see what is that I have written here. So you see that when if you are given a 3 cross 3 matrix like this, then if you are going to you have to go and form the characteristic, that is the characteristic equation like this. I have explained the characteristic equation, how to arrive at the characteristic equation. But after getting the characteristic equation by this lengthy method, you have to make sure that you have got the right characteristic equation. For that, you can go for a checkup in this way. That means you are having a 3 cross 3 matrix. Then the characteristic equation will be lambda cubed minus sum of the diagonal elements, principal diagonal elements. I will call it as principal. This is called your principal diagonal elements. Here I will do. See, here we will check. For this we will check. See, for this, study this and come to this. See, for this it is lambda cubed minus lambda squared into, what is that I have written here? Sum of the diagonal elements. What is the meaning of sum of the diagonal elements here? The sum of the this is your principal diagonal elements. 1, 2, 3. Add all the 3. How much will you get? It is 3. So 3. Then plus. Then lambda. See, here I have written. See, it may be slightly clumsy, but try to understand. I will I will just say what I have written on the board so that it will not cause you difficulty to understand. What I am telling you is that I will read the passage here. That is, sum of the determinants with respect to diagonal elements. What is that I have written here? Sum of the determinants with respect to diagonal elements. Now come to this. This is the principal diagonal element. This is your principal diagonal element. This is your principal. Now take this one. What is the determinant of this one? This is the determinant. With respect to this, this is, so 1 into 1, 1. This is minus 1. So 1 minus 1 will be 0. Can you catch this? 1 into 1 is 1. Then plus 1. 1 minus 1 is 0. So what is that you will do? 0 plus. Come to the next. See, the middle one is principal diagonal element. I am telling you principal diagonal element. So your principal diagonal element is 1. So give up this column, give up this row, multiply. 1 into 1 is 1. 1 into 3 is 3. So 1 minus 3 will be minus 2. So it is minus 2. It is minus 2. Plus, come to this one. Suppress this column and this row. 1 into 1 is 1. 2 into 0 is 0. So this is 1. So what is that you will get? So next is what is that you will get here? Then minus plus, then minus. You have to, what is that? The determinant. That means what? You have to find this determinant which will be equal to 0. Now what is this A? I will write here A determinant is equal to 1 into this determinant. 1 into 1 is 1. Minus 1 into minus 1 is plus 1. Again it is minus 1. Then it is minus 0 into anything is 0 plus 3 into 2 into minus 1 is minus 2. 1 into 1 is 1. So minus 1. So this will be equal to 1 minus 1 is 0. This is 0. This is minus 1. Minus 2 minus 1 is what? Minus 3. It is minus 9. So it is minus 9. So you see that here you will get lambda cubed minus lambda squared into 3. This is nothing but what? You will get here, I will write here lambda cubed minus 3 lambda squared. This is minus lambda. Here the value of this A, we have found it to be how much? It is minus 9. So minus into minus will make it as plus 9, which is equal to 0. Can you see this? So you see that when you are finding the characteristic equation, the way to find the characteristic equation is, say I have given you this, sum of the diagonal elements minus lambda squared into, here lambda squared into sum of the, here I have written here it is lambda squared, I will write here lambda cube, it is lambda squared, it is lambda squared and it is lambda, and you see that lambda cubed into sum of the diagonal elements, lambda cubed minus sum of the diagonal elements, principal diagonal elements into lambda squared minus lambda into sum of the determinants of the principal diagonal elements. I have fully explained everything. Then minus the determinant value of the given matrix. So I have written, see what is that? I hope that all of you should have understood well. Now you see that this is what you get. Now don't you see that this is the same as this? Lambda cube minus 3 lambda squared minus lambda plus 9. So I am totally confirmed that my characteristic equation is correct, and definitely my A will satisfy this characteristic equation. If something has gone wrong in this, you will not get 0 on the right hand side when you substitute the square matrix A in the place of lambda. So you know that very well. So now let us pause on to the verification now. So let me rub off this. So let me rub off this now. So you see that these all, you have to be very carefully doing this plus and minus and everything, otherwise you will not get the problem correctly. So I am rubbing off everything. So I will rub off everything. So what do you get here? Lambda cube. So the characteristic H is what? The characteristic equation is lambda cube. If it is lambda cube, then what does that you get here? Then lambda cube minus 3 lambda squared minus lambda plus 9 is equal to 0. So this is the characteristic equation. Verification of Cayley Hamilton CHT. Now check whether, see what is that you must check? Check whether A cubed minus 3A squared minus A plus 9I is equal to 0 matrix. Now mind that this is a 0 matrix in the sense what? It is a 3 cross 3 0 matrix. It must be like this 0 0 0 0 0 0 0. This is what you should. This is the meaning of that. Okay. Now I will write here your A is what? Your A is 1 0 3 2 1 minus 1 1 minus 1 1. This is your A. This is your A. Now what is your A squared means what? Your A squared is 1 0 3 2 1 minus 1 1 minus 1 1. This must be multiplied by, it is 1 0 3 2 1 minus 1 1 minus 1 1. Now you see that this is equal to, you have to do first row into first column. 1 into 1 is 1. This is 0. 3 into 1 is 3. So it is 4. Then first row into second column. You will get the second element in the first row. 1 into 0 is 0. 0 into 1 is 0. 3 into 1 is 3. It is 3. 1 into 3 is 3. 0 into this is 0. This is 3. So 3 plus 3 is 6. Similarly, 2 into 1 is 2. This is 2, 4. 4 minus 1 is 3. Then 2 into 0 is 0. Then this is 1. And this is plus 1. This is 2. Then 2 into 3 is 6. And it is minus 1 means 5. Then minus 1 means minus 1. 6 means 4. Then 1 into 1 is 1. Then this is minus 2. This is 1. 1 plus 2. This is 0. Then 1 into 0 is 0. It is minus 1. It is minus 1. It is minus 2. Then this is 6. Sorry, this is 3. And this is plus 1, 4. It is 5. So this is what you get for your minus 4. You get what is that you get? I will just take, we will verify. 4 minus 3 is 6. You just see that it is 1 into 0 is 0. It is first row into this one 4. It comes as 103 and everything is 103. 4, just check it up. 1 into 0 is 0. 0 into 1 is 0. 3 plus minus 1. So it is minus 3. It is minus 3. So 4 minus 3 is 6. 3 to 4, 0 minus. So this is correct. So my a cubed is correct. So a squared. Now I'll write here your a squared. So what is your a cubed? A squared into a, that is equal to 4 minus 3, 6. 3, 2, 4. 0 minus 2, 5. And this must be multiplied by 1, 0, 3. 2, 1 minus 1. 1 minus 1, 1. And this must be multiplied. Now, as you have done, if you do this multiplication, if you are going to do this, it will be lead you to 4 minus 9, 21, and it is 11, it is minus 2, it is 11, 1, minus 7, this is what you will get. So I have got a squared and I have got a cubed. Substitute in 3. Substitute. See, you have to verify. Know that this may be this is the characteristic equation. Substitute. See, what is that you have to do? Verify if, what is that? A cubed minus 3, what is your a squared? Where is a squared is what? 4 minus 3, 6, 3, 2, 4, 0, minus 2, 5. Then minus, what is your a? A is 103. Your a cubed, okay? A cubed means is this one. See, where is your a cubed? A cubed is, see, I have written wrongly here. Your a cubed is this. This is a cubed minus 3 into, what is your a squared? 4 minus 3, 6, 3 to 4, 0, minus 2, 5. Then minus lambda in the place of this 103. Then 2 1 minus 1. It is 1 minus 1 1 minus 9 1 0 0 0 1 0 0 0 1. So this is what you get here. Now we will verify this whether this is equal to 0. Now I will rub off this. So what is that you will get here? 4. So you will get this as, so you have to be very carefully doing this numerical work, otherwise you will get things wrongly, and your characteristic equation must be properly found, otherwise you will get it wrongly. So it is 4 minus 9 21, 4 minus 2 11, 1 minus 7 7. Then minus, multiply throughout this, multiply the whole matrix. So it is 12 minus 9 18. Then this is minus 9. See here 12. Okay, no problem. You can put it even minus. See, this is plus of minus 3. Plus of minus 3. So it is minus 12. It is plus 9. It is minus 18. Minus 3, minus 9. Minus 6. Minus 12. 0. 6. Minus 15. Likewise, this is minus 1 into that. So minus 1 into minus 1, 0, minus 3. Minus 2, minus 1, it is 1. Then minus 1, 1, minus 1. Then minus, it is plus actually. It is plus. So we have to be very careful. 9, 0, 0, 0, 9, 0, 0, 0, 9. Now what is that you will do now? Completely add everything. So what is the matrix that you will get here? You will get the matrix to be what? Add all the corresponding elements. First element means completely add the first element in the first row. Completely add. So what is that you will do? 4 minus 12. How much is it? It is minus 8. Minus 9, minus 8 minus 1 means minus 9. I will write only for 1. 4 minus 12 minus 1 plus 9. First row. Then minus 9. It is plus 9. Then plus 0 plus 0. Third one is 21 minus 18 and minus 3. And plus 0. So you see that this is becoming 0. Say this is 12 minus 1 is minus 13 plus 13 0. Minus 9 plus 9 0. Then this is minus 18 minus 3 minus 21 plus 21 is 0. So likewise you can check. Say 4 minus 9 is minus 5. Minus you will get 4. It is minus 5. Minus 5. So if we have to very this thing. So where have we gone wrong? Minus 9. It is minus 2. Let us check 4. It is coming as 4 minus 9 21. Here it is 11. I am sorry. This is I have written wrongly. It is 11 minus 2 11 1. Now you see that it is 4 minus 9 21. 11 minus 2 11, 1 minus 7 7, minus 12 9, minus 18, minus 9 minus 6 minus 12, 0 6 minus 8 15, minus 1 0, minus 3, minus 2 minus 1 1, minus, like that everything. Now you will get. So you see that it is 11, minus 9 minus 2 is minus 11, so it is 0. This is minus 2, minus 8, minus 9, plus 9 0. 11 it is minus 1 plus 1 0 because this is 0. 1 plus 0 is 1, take away 1 it is 0. Minus 7 it is minus 1 plus 1 0. It is 7 minus 15 is minus it is minus 8. Minus 8 minus 1 means minus 9, plus 9 is 0. Now, so this is what you get. So what is that you get? Now this is 0. 4 minus 13 plus 13 is 0. So this is 0, this is 0, this is 0. So what is that you get? It is a 0 matrix, 3 cross 3 0 matrix, and this verifies your Cayley Hamilton's theorem. Here what is that you must remember is that you have to be very carefully doing numerical work, okay, and then finding, you must know how to do the matrix multiplication, okay, then addition, and how everything you must know, then only you'll get. So we have verified the Cayley Hamilton's theorem. Now I'll go to the second part of finding the inverse of the matrix, okay. Now, so this verifies. So verified CHT. So we have verified what? This left hand side, this is equal to 0. We have to verify this, that means we have to verify this. So verified a cubed minus 3a squared minus a plus 9 is equal to 0. Verified. You must write this. And hence CH3 Cayley-Hamilton theorem is verified. Okay. Now let us find out the, what do you call as the a minus 1. Now let us find. To find, I'll write here second part 2. That is second question. To find inverse of a, that is a minus 1 of a, inverse of a. Now I will write here, see, we know that, see, we have verified, so I'll write here, we have verified CHT, that is a cubed minus 3a squared minus a plus 9 is equal to 0. Verified. Okay. Now this is verified. Now I'll write something here. So to find a minus 1, let us find a minus 1. To find a minus 1, I'll write here. To find a minus 1, you call this as we told, this is I will call this as my 4. To find a minus 1, multiply 4 by a minus 1, that is a minus 1 into a cubed minus 3a squared minus a plus 9 is equal to 0 into a minus 1, that is equal to 0 into anything is 0. So this is a 0 matrix because you are going to multiply this 0 with all the elements of a minus 1, that will result only what a 0 matrix. So don't worry about that. Now take this inside. So when you take this inside, it is a minus 1 into a to the power of 3 minus 3a minus 1 a square. It is a minus 1 a plus a of a minus 1 is equal to 0. We know that a minus 1 is equal to I. That means what? A matrix multiplied by its inverse will give the unit matrix. That is, here in this case it's a 3 cross 3 matrix, that it is 1 0 0 0 1 0 and 0 0 1. That is what we understand. Now it is just like your theory of indices. What is that you will do? A cubed into a to the power of minus 1 is equal to a square, 3 minus 1. See, a to the power of 3 minus 1, that is equal to a square. Apply the same apply the theory of integers here. What is that you will get here now? So you will get this to be what? It is a squared, that is a squared minus 3a minus, this is your I means unit matrix, okay, I plus 9a minus 1 is equal to 0. So this implies 9a minus 1 is equal to minus a squared plus 3a plus I. So this is equal to I plus 3a minus a square. This implies a minus 1 is equal to 1 by 9 of, it is I plus 3a minus a squared. So this is equal to 1 by 9 into I is 0, 1, 0, 0, 1, 0, 0, 0, 1, 0, 0, 0, 1. This is your matrix. Minus 3 into, what is that you will get? A is, what is your A? It is 1, 0, 3. It is 2, 1, minus 1. And it is 1, minus 1, 1. Then minus a squared. What is your a squared? A squared is 4 minus 3, 6. Then it is 3, 2, 4. And it is 0 minus 2, 5. Okay, now this is equal to, so this is equal to 1 by 9 into, this is 1, 0, 0, 0, 1, 0, 0, 0, 1, minus, through out multiply, 3, 0, 9, 6, 1, minus 3, 3, minus 3, 3, minus 4, minus 3, 6, 3, 2, 4, and 0, minus 2, 5. So this is what you will get. Now I will write here then. So what is that you will get here? So do the simplification properly, so that here you see that 1 plus 3, 4. See, 1, it is minus 3. 1 minus 3, see, it is minus 2. It is minus 4, minus 6. So what is that you will get here is, I will just, if I tell you, it is minus 4, it is like this, minus 4, 3, okay, whatever we get, we will solve it. Now what is that you will get here? So this is 1, here it is plus, actually this is plus, here it is plus, and here it is minus, it is plus. So it is 1 plus 3, 4, 4 minus 4 is 0. So this is your 0. Then 0 plus 0 is 0. This is minus into minus is plus. So it is 3. It is 3. And then it is 0. It is 9. 9 minus 6. You know how you are getting this? So you have to take this minus sign inside. If you want, I will write one more step so that you will understand. So what is that you will get here is 1, 0, 0, 0, 1, 0, 0, 0, 1 plus this is 3, 0, 9 and it is 6, 1 minus 3 and it is 3 minus 3, 3. and this must be added with, take this minus sign inside, it is minus 4, 3, it is 6, see, it is plus 3, it is minus 6. Take this minus sign inside, minus 3, minus 2, minus 4. Then it is 0, 2, minus 5. So I am taking everything inside. So let me, it is easy for you now. So this is 1 by 9 into, now you simply add, 1 plus 3 is 4, 4 minus 4 is 0. 0 plus 0 is 0, it is 3. 0, 9, 9 minus 6 is 3. 0, 6, 6 minus 3 is 3. Then 1, 1 plus 1 is 2, 2 minus 2 is 0. Here let us check, it is minus 2, it is 1 by 9 into minus 4, 3, minus 6, minus 3, minus 2, minus 4, 0, 2, minus 5, 3, 0, 9, then 6, 3, 3, here it is 3, yeah? It is 6, 3, 3, it is 6, 3, 3, it is 3, see, 3 into 2 is 6, 3 into 1 is 3, 3 into minus 1 is minus 3, so here, so that's why I told you have to be very careful. So you see that it is 0, 6, 6 minus 3 is 3, 1 plus 3, 4, 4 minus 2 is 2, 4 minus 2 is 2, then it is 0, minus 3, it is minus 4 is minus 7, then 0 plus 3 is 3, 3 plus 0 is 3, then it is 0, it is minus 3 plus 2 is minus 1, 1 plus 3, 4, it is minus 1. So this is equal to 1 by 9, 0, 3, 3, 3, 2, minus 7, 3, minus 1, minus 1. It is the a minus 1. A minus 1 is this. So we have got this a minus 1. Now I have found a minus 1. But how am I sure that this a minus 1 is correct? Now you tell me how this is correct. So I do not know whether this a minus 1 is correct or not. So you have to verify again whether a minus 1 into a is equal to unit matrix. So verification. So we have got, I will write here. So a minus 1 is, so using Cayley Hamilton's theorem, you are able to get the a minus 1. That is, a minus 1 is found to be how much? A minus 1 is equal to 1 by 9 into 0, 3, 3, 3, 2, minus 7, 3, minus 1, minus 1. So answer. So this is your answer for this one. Verification. Now how to verify? Check whether this is correct. Check whether a minus 1 is correct. Check. To check whether a minus 1 obtained is correct. That is, verify a minus 1 is equal to a minus 1 is equal to I. Now what is your a? What is your a? A is equal to, what is your a? 103. And it is 2, 1 minus 1. 1 minus 1, 1. This must be multiplied by 1 by 9 into 0, 3, 3, 3, 2, minus 7, 3, minus 1, minus 1. That is 1 by 9 into 103, 2, 1, minus 1, 1 minus 1 1, multiply this by 0 3 3, then it is 3 2 7 and is 3 minus 1 minus 1. So this is equal to 1 by 9. Now multiply this first row into first column. 1 into 0 is 0, 3 into 3 is 0 into 3 is 0, 3 into 3 is 9. First row into second column, 1 into 3 is 3, 0 into 2 is 0, then 3 into minus 1 is minus 3, plus 3 minus 3 is 0. 1 into 3 is 3, 0 into 7 is 0, my 3 into minus 1 is 3, so 3 minus 3 is 0. 2 into 0 is 0, then 1 into 3 is 3, minus 1 into 3 is 3, therefore it is 0. Then 2 into 3 is 6, 1 into 2 is 2, minus 1 into minus 1 is plus 1, so it is 9. 2 into 3 is 6, 1 into 7 is 7, so it is plus 1, so plus 7, minus 7 and plus 7. 2 into 3 is 6, then it is 7. So here let me check whether 103, it is 033, 3 2 minus 7, see, it is 3 2 minus 7, 3 2 minus 7, see here minus 7. So you see that what is that you get now? 2 into 3 is 6, then 1 into minus 7 is minus 7, so 2 into 3 is 6, 1 into minus 7 is minus 7, minus 1 into minus 1 plus 1, 6 plus 1 7, 7 minus 7 is 0. Then 1 into 0 is 0, minus 1 into 3 is 3, 1 into 3 is 3, therefore 0. 1 into 3 is 3, minus 1 into this is minus 2, it is plus 1 into minus 1 is minus 1, minus 3 plus 3 is 0. Then 1 into 3 is 3, it is plus 7, it is minus 1, you will get what? It is 3 plus 7 is 10, take away 1, it is 9. So okay, this is your I. Then what is that? A minus 1? A minus 1 will be what? 1 by 9, 0, 3, 3, 3, 2, minus 7, 3, minus 1, minus 1, into 1, 0, 3, 2, 1, minus 1, 1, minus 1, 1. You verify. See, 0 into this is 0, this is 6, 6 plus 3 is 9, this is 0, this is 3, minus 3 is 0, this is 0, this is minus 3, plus 3 is 0, 3 into 1 is 3, this is 3 plus 2 is, that is 3 plus 4 is 7, minus 7 is 0. 3 into 0 is 0, then it is 2, then it is plus 7, it is 9. Then next is automatically, you just check it up, 3 into 3 is 9, it is minus 2, minus 7, minus 2 minus 7 is 9, so it is 0. And then 3 into, see, this will be 0, check, let us check now. 3 into 1 is 3, minus 2, minus 3 0, 3 into 0, minus 1, plus 1, 0, 3 into 3 is 6, this is 3 3s are 6, then this is minus 1, plus 1, then you get, how much will you get here? 3 3s are 9, 3 3s are 9, and this is minus 1, plus 1, see, this is plus 1 and this is minus 1, will give you 9. So this is equal to, throughout divided by this, 1 0 0 0 1 0 0 0 1, and you find that what a minus 1 a is equal to a minus 1 is equal to I. So this verifies that our inverse of the determinant square matrix got is correct. So this is how we verify the Cayley Hamilton's theorem. Cayley Hamilton's theorem simply states that every square matrix satisfies its own characteristic equation, and you have to verify that and forming the characteristic equation. Given a square matrix, you form the characteristic equation and write that and substitute in the place of the characteristic value, namely lambda, the square matrix, and see whether it is equal to 0. And then if you want to find, you can use the Cayley Hamilton's theorem to find the inverse of the matrix. So let us see more and more in the coming classes. Thank you.